Hey friends, welcome to the blog. This is part of the way from SPD Hobbies. Please check out my other videos. Alright, now today's video is gonna be about motors. Alright, motors, the thing that powers our RC vehicles, the thing that powers all our stuff. Right, they are used in various stuff. Now the thing is, motors, there's maybe a little bit of concern about it, because that is the thing that powers our vehicles and stuff. So that's got to be right. Alright, the choice for the thing. Many times there are confusion regarding lots of specifications and motor sizes and motor types, how to drive them. Alright, I'll try my level best to clear some of the doubts. Alright, please comment in if you have any more suggestions about the things, like if you want to ask something on stuff, and I'll get back to you. Alright, now let's get started. Now, motors, what can we define motors as? We can define motors as devices which will convert electric motors that I'm speaking about, that will convert electrical energy into rotational mechanical energy. Okay, that's the simplified terms. Now let's see what are the types, or what are the categories, as obvious in science. So the thing is, let's divide the motors. Okay, first of all, we can divide the motors into two types. Easy hobby stuff. All right, the thing is, brushed or brushless. All right, now let's get into brushed. That's the easiest stuff. These, see them? All right, yep. So thing is, I hope if you have been in hobby, or if you have been flying, like using RC vehicles for a time, you recognize these motors. Okay, now this one, the first one is a brushed 380 motor. All right, now these are why we call them brushed, because you have two pads on both sides of a rotating armature. All right, and the thing is, the magnet inside, or the coil inside, rotates, and the permanent magnets stay in the place. All right, they don't rotate. So the problem that it makes in this design is that, as you're seeing a rotation out here, you're gonna have frictional energy out there, and the thing is, they heat up very fast. All right, and over time you're gonna end up wearing the brushes, which means you need to either replace the brush, which is difficult in most of the times, or you gotta get a new set of motors. All right, now these are the coreless ones. Coreless, there's a magnetic core present inside these. If I could have shown them, I could have shown you. The thing is, let's leave the thing. The thing is, it has a metal core. Okay, the armature has a metal core, and over there the winding passes, but in this thing you just have the winding, you don't have the core. So that's their coreless. Basically they're similar make, they are having brushes at the ends, they're having armature out, where you can just get the the energy coming out, the rotation energy coming out. The thing is, these are dependent on the current, or like moreover we will say the potential, the voltage that is being supplied to them to control their rotation. Although they have a limit, but still this is the way their speeds are controlled. All right, the thing is, how do you alter them, or how do you drive them? Let's talk about their RPM. Let's talk about kV. All right, kV, like let's say kilovolts. No, that's not kilovolts. Okay, kV rating of a motor will define that how many times, how much RPM, rotation per minute, this motor is achieved to is able to give per voltage. Okay, so that is the kV rating. So for instance, for example, if you have a 1000 kV motor, all right, and you're running it at 10 volts, you're gonna have 10,000 RPM. Pretty clear, no problem. All right, so the thing is, these motors, the advantage is simple to use, but the disadvantage is they wear out with time. They're not reliable that much, compared to the other category. How you drive them is, you can use, if you want to control their speed, like if you want to just control on and off, you can use a switch. All right, capable switch of handling the current. But if you want to, like in the RC vehicles, in these kind of helicopters which you have, the toy level helicopters, or in other car applications, what they do, or what the brushed EAC or the drive system, power system does, is they use NFETs and PFETs. All right, P channel, ion channel transistors, or MOSFETs, to drive them. What they do is, at the gate of the transistor or the MOSFET, what they do is they supply a varying voltage. All right, they do it by their own ICs and logic systems and stuff. So that is what drives them. Okay, they actually tend to change the current, which actually adjusts the potential in there, that's running the motor, and that is the way you get the thing, to turn up the speeds and off, turn on, off them. Okay, these are used these days, these are used in toys. All right, you can just Once it wears out, don't try to don't try to repair it, because it's impossible to keep them running after repair. All right, you just get a new pair. Not much to talk about them. Let's get into the other important aspect. That's these days brushless. Yeah, you're talking about brushless. Now the thing is, in brushless motors, what's their main advantage? Let me show you how they look first. All right, this is, there are 4 brushless motors I've installed on my 450 frame. As you can see, these are having 3 wires. Now you ask them, if you provide the voltage terminals, there 2, what are we doing with the 3 wires? And that's a confusion out there. And what's this yellow thing out here? All right, let me answer all of your questions. Now, firstly, in brushless motor, the main difference is you do not have the permanent magnets fixed. You have them moving. All right, so that means that the coil is fixed. The magnetic coil is fixed in its place. And what's the advantage is that you just have 2 bearings, that's taking that friction. So you have less parts wearing down and like no electrical contact with the moving parts. So that's what along like elevates its lifetime. Okay, now controlling brushless motors and everything. I'll just that form of kV, the formula of kV, what I taught, what I talked about, applies to these as well. kV, like these are, as you can see, 850 kV. All right, 850 kV. You do the math. You're running it at maybe say 12 volts from the lithium polymer batteries like these. So you just do the math and you get a rating. Now you most of the time we don't drive them to their the max. That's not what we do. So you can calculate a nominal kV. Let's get into how to drive them. All right, how to get a brushless motor running. Thing is, brushless motors, they're gonna have 3 wires, like they're 3 phases. Okay, they're 3 phase. The interior coil is divided into these 3 phases. Now what you need is an alternating current, AC, to run them, and that too in a controlled form. So that is what this thing does. What it does, or what it is an ESC, electronic speed controller, and this one has a thing called BEC. We'll talk about it all. Alright, now as you can see, it is wires. Now let's talk about what the wires do. These 3 wires, these go into the motor terminals. Alright, there's a black which goes to the ground, and there's a red which goes to the positive voltage of the battery. Alright, or the circuit system we are running with. And you have a signal wire out here. Alright, this is the thing. Alright, and you have you're gonna have a positive out there as well. All right, this is the positive. It has been drawn out because it was used in some other form. All right, now you're gonna have it at the center. So let's fit in this wire like this. All right, this is the way. All right, now let's talk about the color codes and stuff. Now this is the signal wire. All right, now since this is a BEC equipped, that is battery eliminator circuit equipped, in RC there are 2 parts. All right, there's a hot part and there's a cold part. Now the cold part is the logic part, the cool part, whatever you can call it. I call it hot and cold part. Interesting. Alright, so thing is, the cold part, like these flight controllers which you have, or the receivers which you're gonna have, they run at 5 volts. Okay, they cannot take these 12 volt giant voltage stuff and things. Okay, they'll burn out, simply burn out. So thing is, these guys have a BEC. Typically they are 7805. 7805 ICs. You can just search them online and you'll get this component 7805. Okay, and 7805, what it does is it regulates the voltage no matter what the quad is running at or the vehicle is running at. What it does is it regulates it and makes this red wire provide 5 volts. All right, and that is what saves the circuitry. Now the ground, the black one, in all ESC applications you would want only one ground to be there throughout the vehicle. All right, you can have potentials like 5 volts, 12 volts from that red wire. The thing is, you need one ground. Why? Because you need a signal to travel through these wires and be differentiable, like they are being able to feel it through the ground. Let me explain. Take this as a base level. This is the base level, and this supplies the PWM structure. See, I'll make a video on these signals. You can check them out. All right. So the thing is, these supply PWM. So if you have a common ground, it becomes easier for all the ESC servos and everything to detect this PWM. All right. Now the red wire, it's been detached here because this was being used as a shared system. Not a big deal. All right. Now the thing is, through these 2 wires that you are seeing, all right. Through these 2 wires, what it does, it gives in a great amount of voltage, like say 12 volts or 14.8, 16 volts or anything. And what this interior circuitry does is it uses MOSFETs to make alternating current AC, chopped off AC through this end as per the signal being given through the white wire. Okay, and this is where the motor gets connected and it gives out pulses like that kind of thing. All right, it just switches on and off, and at that too at a very high speed. That is what makes this guy running. All right, and the thing is, there's another thing, interesting thing about this brushless motors is that if you connect it this way, say black, yellow, red, that is the order you have, all right, or red, yellow, black, all right. If you just change a pair and make this red, black, yellow, or yellow, black, red, then what it does, it reverses the direction of the motor. All right, that's pretty simple. And I can give you one more idea. If you want to use this as a reversible ESC at low cost and cheap, like if you're like a jugaad, you want to make jugaad stuff, so what you can do is, Indian term jugaad, all right, what you can do is just use like a switching mechanism, like a relay, okay, to switch this over, all right, through a signal. And what it would do is it will in turn relate to this motor and will turn reverse. All right, the advantage of these motors are they're really efficient, reliable, they can keep running long time, you know, and you're having less amount of energy wasted through friction. All right, so let's see them running. All right, now friends, here there's this the component in hobby, we call this servo tester. All right, servo tester, what it does is it takes an analog input through this potentiometer, takes a analog input, and through an integrated IC, what it does, it gives output just like any receiver. But the advantage is that here you are like you are betting on a little bit of money, like say 150 or like 200 rupees max, 200, 250, like in that range. So the thing is, you're risking a little less. Now let's see this friend running. All right, I don't think you'll be able to recognize the direction it's rotating in, but yeah, let's go with the thing. All right, let's check this thing out. I just took it up. All right. You heard that? That's actually the initialization of the motor. And the other motors, they are not being given a signal, so they won't. All right, now you can see the knob. All right, start rotating it. That's the other motor that I've connected. Sorry friends, I'll just show you that motor. All right, let's get the knob rotating. All right. Yeah, so tremendous speed, and moreover, what advantage, let me disconnect this, just give me a second friends. All right, another thing is the advantage that you have over the brush motors is that previously brush motor used to have like high RPMs, but they were low in the torque. But these guys, they are pretty good at the torque. All right, so you don't need any gearing system, you just mount the props directly, and that's enough to carry even bigger props. Say these guys are meant for 10 inches, 11 inches prop, no problem for them. All right, so this was the kind of discussion we had on motors that I had around. You have one more type of thing, that's the servo motors, what we call. They are generally used to control surfaces and stuff. They just give out a signal on these kind of wires. They run on this kind of wires, and what it does is it translates a signal into their their respective positions. Not a big deal, I'll just make a few videos on that as well. Okay, enjoy flying friends, fly safe, operate safe. All right, and good luck with all the stuff. Please keep commented, keep me posted of the happenings, and if you face any problems, just leave out a comment I'll surely get back to you. All right, bye friends.